Long before the invention of the telescope, our ancestors looked at the night sky and noticed a single point of light that defied the pattern. While the white stars twinkled, this one held a steady crimson glow. This celestial body has been a source of myth and wonder for centuries. Which planet in our solar system is known as the red planet? The four planetary candidates are Venus, Mars, Jupiter, and Saturn. Identifying this world requires looking past its color. By examining the physical evidence gathered by modern science, we can separate the true target from the other three candidates. Every planet is defined by its environment and physical makeup. To reach the truth, we have to look beneath the telescopic appearance and investigate what these worlds are actually made of. We begin with the physical structure of the world. Our target is a terrestrial planet, meaning it has a solid, rocky crust that a spacecraft could physically land on. This immediately removes Jupiter from consideration. Jupiter is a vast sphere of hydrogen and helium gas. Any spacecraft attempting to land would simply sink through thousands of miles of atmosphere until the intense pressure crushed it. There is no solid ground here. Saturn follows the same pattern. Despite its iconic rings, the planet itself is composed of fluids and gases, lacking any stable surface for exploration. Because massive size in our solar system usually results in a gaseous state, these outer giants cannot be the world we are looking for. Our search is narrowed to the smaller, denser worlds of the inner solar system, where rock and metal dominate. This leaves Venus and Mars. While both have rocky surfaces, our target is a freezing, arid desert. Venus fails this test. Wrapped in a crushing atmosphere of carbon dioxide and sulfuric acid clouds, it is the hottest planet in the solar system. Surface temperatures stay high enough to melt lead, day and night. Radar mapping reveals a world of volcanic plains and heat-distorted rock. It is the opposite of the frozen environment we are identifying. Through this process of elimination, we find our answer: Mars. Its appearance is the result of chemistry rather than heat. The Martian surface is saturated with iron. Over billions of years, this iron reacted with trace oxygen and moisture to oxidize. The planet is covered in a layer of iron oxide. Essentially, the world has rested. This global layer of dust gives the planet its signature hue, hiding a landscape shaped by billions of years of geological history. Descending from high orbit reveals a harsh, alien geography that completely dwarfs anything we have found on Earth. This is Olympus Mons. It is a shield volcano that rises nearly 16 miles above the surface. Its height is tripled out of Mount Everest, making it the largest volcanic structure in the solar system. Further across the equator lies Valles Marineris. This canyon stretches over 2,500 miles, spanning the United States. Because Mars lacks active tectonic plates, the crust remained stationary over hotspots for eons, building features of immense scale. This lack of movement has turned the planet into a massive archive, preserving these gargantuan structures for billions of years in a deep freeze. We have spent decades exploring this world through the lenses of robotic probes, studying the chemical composition of its rocks from millions of miles away. Modern rovers now travel across its basins, searching the soil for microscopic evidence of past habitability and biological potential. These missions provided a breakthrough: the discovery of gullies and mineral deposits that could only be formed by liquid. They are the undeniable footprints of ancient flowing water. This evidence suggests that billions of years ago, Mars was a vibrant blue world, with an atmosphere thick enough to support lakes and rivers. Understanding this history is the foundation for our next era of exploration. Plans are already underway for crewed missions that will turn these robotic landing sites into the first human outposts on another world. What began as a mysterious red light in the sky has become a roadmap for our expansion into the stars. Each secret we uncover on Mars brings us closer to the day when humanity finally sets foot on its rusted soil, bridging the gap between our home planet and the rest of the solar system.